All right, this is the definition of a conjugate. The conjugate of a complex number is in the form a plus bi and a minus bi. So what you're changing is the sign in front of the imaginary piece. So complex conjugates of each other are a plus bi and a minus bi. When we FOIL out complex conjugates, the middles will cancel, so I just want to show this to you. So here are complex conjugates. We FOIL. We get first, outside, inside, last. The middles cancel. Then you replace that I squared in the second term with a -1. And then -1 turns to a +1. So the rule is when you multiply conjugates, you only have to worry about the first and the last, and then the middles and the i's cancel out. All right. If you're not comfortable with that rule, just FOIL it out. So perform this indicated operation and then write your result in standard form. So we have a complex number dividing another complex number. So what we have to do is we have to multiply the numerator and the denominator by the denominator's conjugate. So what's the conjugate of that denominator? It's 4 plus I. So we're going to multiply the numerator and denominator by the denominator's conjugate. And now we multiply across. So I'm going to multiply the numerator first, so I'm going to FOIL it. So 5 times 4 is 20, outside, 5i, inside, 16i, last, 4i squared. Denominator, FOIL it. I'm going to show you how that works again. So again, those middles will cancel. So first, outside, inside, last. Simplify. Combine your middle terms. And what happens to this I squared? It changes it to a -4. In the denominator, the middles become 0. This I squared becomes -1. So -1 becomes +1. Continue simplifying. 20 minus 4 is 16 plus 21i over 16 plus 1 is 17. Now we put it in standard form. So standard form says you have your real part plus or minus your imaginary. In this case, it's a plus. This is standard form. Principal square root of a negative number. So here is the rule. Notice the difference between these two. The first example on the left is correct. You have the square root of -25. That represents I squareds of 25. Then you have the square root of -4. That represents I squareds of 4. And then you would simplify those radicals and combine to multiply, and then replace the I squared with -1, and you're done. Notice the difference with the right-hand side. Incorrectly were to be multiplying these two together underneath the radical because they are considered imaginary or complex. So you can't combine them together. All right, so here's our example. We want to simplify so that negative square root of 18 represents I square roots of 18 minus I square roots of 8. Then we break down that 18 to the square root of 9 times the square root of 2 minus, break down the square root of 8, the square root of 4 times the square root of 2. Now the square root of 9 is 3, so that's 3I square roots of 2. Go to the next term. The square root of 4 is 2, so you have 2I square roots of 2. These two terms are alike, so we can combine their coefficients. So 3I minus 2I is 1I square roots of 2, or I square roots of 2. Next example. This parenthesis squared represents a binomial times another binomial. So before we fill those out, I'm going to change those negative 5s to I square roots of 5.
She's not allowed to be there.
Shh, shh, shh. Go ahead.
She's not. She wasn't allowed to be
Alexis, I'm recording a 7-minute video. Okay, I'll be there in a minute.
She's not allowed to be there.
So negative 1 times negative 1, as we're going to start to FOIL, is 1. Then outside, then inside, then last. Last is going to be I times I is I squared. Square root of 5 times square root of 5 is 25. Continue simplifying. These two are alike, so we're going to combine them to negative 2I square roots of 5. Last, I squared is negative 1. Square root of 25 is 5. Combine here to give you positive 5. 1 plus 5 is 6. This answer now is in standard form.